Hello everyone, my name is Naveed Illyas and today I'm going to present my research work on single image crowd counting, and the topic of my research is dense feature extraction for crowd counting in an image. Here are the list of contents. So without wasting any time, let's move toward the related work and motivation. We came up with the four most relevant latest research works, and the first one is MCNN, which is multi-column neural network, convolutional neural network. It composed of multiple columns, and each column has different receptive fields to tackle the different scales. However, author in 5 claims that all of these columns obtained the similar type of features. Inspired from MCNN, a switch CNN is proposed. It is also a multi-column network with an addition of switch, which basically relay the patch to a particular regressor which is already trained on a different image patches. Like the one regressor is trained on low image patches, other is high, and next is high density image patches. However, it also restricts to obtain the similar type of features. Compared to the above two algorithms, the third one is CSRNet. It is not a multi-column, it is a single column network with a backbone composed of VGG16 and with a dilated convolutional network, and the dilated convolution is very important to obtain the contextual information. However, as the dilation rate goes higher and higher, the pixel loss and information loss is a great drawback in this proposed technique. Next is Hydra CNN, is a regression based technique. It is basically a scale aware model, and the input, it is a multi-scale feature extraction model which depend upon the image pyramid. The feeding images are feed in the shape of pyramid. However, it has some limitation in terms of propagating the information to higher layers and transferring the task independent features to task specific features, especially to higher layers. So observing this most relevant research, we came up with the following motivation: feature dissemination, spatial information loss, and lack of interdependencies among channels. As the feature from the lower layer goes to higher layer, it disseminated, and the information from the lower layer are not fully utilized at the higher layers, and the task independent features at the lower layer and task specific feature at the higher layer are work independently. And it has also spatial information loss due to downsampling, and spatial aware feature which is obtained at the lower layer are not directly passed to the higher subsequent layers. So motivated, and also it has a lack of interdependencies among channels. So motivated from the above mentioned deficiencies, we proposed a dense feature extraction module for accurate crowd counting in an image. So here is our proposed network, which is composed of 3 modules named as general feature extraction module, dense feature extraction module, and fusion module. GFEM is very much reliable to obtain the simple to complex feature, whereas the DFEM is further expanded and it has multiple DSCs and this EDSC is further expanded on the right hand side of diagram. So GFM is used for simple to complex information, where the DFEM is used to propagate the information from lower layers to the higher layer. Hence, task independent features at the lower layers are transmitted to the higher layers, and it also used to reduce the spatial information loss. So the dense feature extraction module composed of multiple DSCs, as I discussed in the previous slide, and the each DSC is further divided into multiple groups, and each group is composed of multiple convolutional layers with a different channel size, whereas each group, for example, G1 is sending the information to G2 and G2 is sending to the G3, and while G1 is directly sending to the information to G3 as well. Finally, we have a fusion module, which is used to fuse the inputs coming from the multiple DSCs. So here is the outcomes of our proposed algorithm DFE crowd. Like there is a general interdependency among different channels in the DSCs like G1, G2 and G3 to obtain a semantic features at the higher layers for accurate crowd counting, and the task independent features which are extracted at the lower layers are propagated to higher layers by using the dense connections. Hence the spatial information which is obtained, which is present at the lower layers, are propagated to the higher layers. So in this way, the combination of the spatial information and the most semantic and the most relevant information at the higher layers, high level information is combined at the higher layers, which increases the accuracy. So this model is basically composed of an effective combination of VGG16 based dense feature extraction module, VGG16 based general feature extraction module, and in densely connected DSCs based model, and the combination of these two are very effective to obtain the accurate crowd counting. Here is the framework what we have used, like PyTorch, optimization algorithm, learning rate and pre-train, number of epochs and batch size. You can see in this table that we have a comparable performance of DFE crowd on the Shanghai Tech Part A and Shanghai Tech Part B, whereas we outperform the state-of-the-art algorithm on Venus dataset. This is because of preserving the spatial information at the lower layers and then propagating it directly to the higher layer with the help of dense connection, and also obtain the rich feature, simple to complex feature with the help of GFEM. So in this way, the task independent and the task general features are combined in such a way that are helpful to obtain the good counting accuracy. So here is the conclusion of our research work, that our research work is very contributive in terms of, like, it has a strong feature extraction property, especially the GFEM general feature extraction module, which is inspired from the VGG16. It is very useful to obtain the simple to complex feature, whereas the subsequent model like the DFEM dense feature extraction module, which is composed of multiple DSCs, and these DSCs are used to obtain the task independent or task specific features and special information to higher levels. In this way, it is very useful to obtain the high counting accuracy. Here my reference Thank you for listening. If you have any question, you can ask. Thank you so much.